The first video, we have seen how to use PyPDFForm to come up with a minimal example to fill a PDF form, as we can see the script on the left side. One of the things I'd like to highlight is that in our example, we did pass this sample template.pdf via a local disk file path to our PDF wrapper constructor, right? That's not very common when you are using PyPDFForm, or I should say when you are using Python in general when building a web service. In fact, it is often wrong to use any form of disk files when you're building web services, especially when you are utilizing things like multi-threading or multi-processing, because you might be running into risk conditions when multiple threads or multiple processes are fighting for the same disk files at the same time, right? So what does PyPDFForm do to address such problem? Well, the truth is that PyPDFForm actually allows you to operate entirely in memory rather than having any form of disk interaction if that's what you want. So the way it does it is by implementing a file adaptation mechanism that will be seen in just a moment. So let's take a look at that. What I'm going to do is I'm going to move this fill method further down, and then we will want to adapt the sample template.pdf in what PyPDFForm offers three different ways. So we have seen right here we're doing it via a local file path already, right? And the two other ways you can do it are a open file object and as well as a binary data stream of the content of this file. So we'll see both here. And the first one we're going to see is actually the open file object. So what I'm going to do is right here, we're going to do with open sample template.pdf. And because PDF exists in the form of a binary file, so you're going to do the access you need is RB. And then for our PDF object, we're going to do PDF equals PDF wrapper. So we'll still want to instantiate our PDF wrapper, except instead of passing the file path to the PDF wrapper constructor, we're going to do the open file object we have just created using our context manager here, right? So that's the first way you could do it. If we go ahead and run this, you will see that the output.pdf will look the same as if we were to construct our PDF wrapper object using a file path. And then the second way is to use the data stream. So in this case, we have f as the open file object. You could also do f.read, and that will read the binary content of the PDF, which is in this case sample template.pdf. And you can also feed that data stream into the PDF wrapper construction, right? And then if we go ahead and run this, we will see that it's the same effect as open file object as well as the local file path, right? So either one of these three work. And the reason behind this is that if you're interacting with files on object storage service, such as like let's say S3 in the case of AWS, they often come in the form of an open file object if you're using their SDK, like Bodo 3, for example. But when you are dealing with client-side uploads, let's for example, when you have you have like a React app that uploads a PDF file to the server side, often than not you will be getting a binary data stream. So PyPDFForm allows adaptation of either, right? And in that case, you won't be seeing this sample template.pdf on the disk anymore. Instead, you will just construct your PDF wrapper object using either the data stream that came from the front end, or maybe an open file object that came from interacting or downloading from S3, for example, right? One last thing is that this file adaptation doesn't just apply to this construction of PDF wrapper object. There are elsewhere when using PyPDFForm that you will be needing to interact with certain form of files. For example, when you have to fill a image field, that we'll be covering later, you will need to provide an image, and of course, an image is a file that needs to come in some form. And in those cases, when you need to interact with any kind of file, this file adaptation will always be a consistent way across the spec of PyPDFForm.